Awesome. Thanks a lot. Thanks for the introduction and for the invitation. Happy to conduct the last session for the day, kind of a late night session. At least in Germany, it's already dark outside. So I chose to opt in for a rather sunny background, which we don't have here currently. So let me start with sharing my screen. You should be able to see my slide deck right now. And yeah, as already mentioned, we'll start with a presentation about combining orchestration and choreography for a clean architecture. And we are taking a look at a couple of things during this fun talk. So if you have any questions, feel free to drop them into the chat. We will have a couple of minutes afterwards to go through them, and I will try my best to answer them all. So let's get started. First of all, with a little introduction. My name is Thomas. I'm a BPM consultant at Miragon, a rather young company focusing on consulting for software architecture, business process management, and process automation based in Augsburg. And yeah, currently I'm actually not in Augsburg. I'm in Hamburg. I've been just at a meetup, had another talk there. Somehow my calendar had a hitch up, but now I'm there just for you. And so now in Hamburg, not in Augsburg anymore, but tomorrow again I'll be in Augsburg. So what will you learn, or what can you expect in today's session? First of all, we'll take a look on the challenges which occur in distributed systems. For instance, how to handle exceptions or how to cope with retries, all these kind of things. We'll see what kind of problems there are and maybe how orchestration can help. So that's the second topic for today, and I will just choose to opt in for this laser pointer. So we'll try to apply orchestration to the problems which occurred in this first session or in this first section, and also introduce kind of a workflow engine. So that might be interesting. And once having done so, we'll then go over to how we actually can write clean architecture, clean code by introducing the hexagonal architecture, and also elaborate a bit how you can really write technology neutral code without including external dependencies in your domain. Then the last topic is all about scaling up in terms of teams. So that means we not only have one domain we want to focus on, but multiple ones. And therefore, we want to introduce choreography. We want to introduce domain events, domain-driven design to really handle these kind of things all together. So we'll see how we can actually mix up orchestration and choreography. And in the end of the talk, you hopefully know how to do it. So let's dive into the challenges right now. And to set the scene, we'll talk a little bit about pizza. Hopefully you have eaten already for dinner or lunch or whatever. Maybe afterwards you'll need to do so, because the showcase I brought today is kind of food-centric. We'll talk about a restaurant which serves pizza, cheeseburgers, hamburgers, whatsoever. And they have actually implemented a new digital waiter. So small tablet based on each of the tables in the restaurant, and visitors or customers can then actually purchase their meal through a web application, and then everything is handled from the backend, more or less. Cool. So how does this work? As you can see, we have this rather small front end here. It's not beautiful. I'm not a front-end engineer by any chance, and I'm very bad at it. But we have kind of a little welcome to pizza and wine place. We want to order pizza margherita. I've entered my name, and then simply I hopefully get some. But there can be quite some worst case scenarios if I don't cover them. So I need to really focus on how to avoid something which happened here. So imagine in the restaurant, our cook, our chef in the kitchen goes on a break and isn't available anymore. So in that case, we cannot deliver any messages anymore. That would be kind of bad. So if our service depends on the availability of another service, we have kind of such a bad practice. And yeah, for sure, we want to avoid that. So we need to make sure to somehow manage user experience in case these things pop up. And also, what does happen if we cannot recover from these mistakes, when there is no retry built in? So all these things I need to try and be aware of when building a web application, which can be quite a challenge. So, oops. Shifting over to the next slide, I tried to summarize all of these challenges which can occur. So in general, when using these kind of synchronous blocking communications, for instance, between our digital waiter, which we call, or whom we call James now, and for instance, a kitchen provider, a payment provider, which are external systems, there can quite some things go terribly wrong. For instance, if the service availability, as mentioned, if James depends on the kitchen being available and otherwise cannot work. And in addition, we do have these kind of implicit change. When we order something, we go over, for instance, to the kitchen provider, then back to James, the digital waiter, and to the payment provider. That's also usually not the best idea. And to make things even worse, we do have long-running tasks. So for instance, when our front end says, okay, please order or please provide a pizza, this can take some time. And we need to simply make sure to handle kind of these communications, these integrations to external systems. And these are kind of the most common challenges, I guess, that all of you know in distributed systems. Cool. So now let me introduce to you the concept of workflow engines, because they can solve quite some things. And first of all, we do have a scheduler, which actually can wait, can retry, and we also can do things like escalation. We can deal with the saga pattern, if you ever heard of it, which means basically we can compensate tasks. It provides a durable state. We know where we are in our process, and everything is persisted. And last but not least, through these kind of workflow definitions, we gain some visibility, which can be a huge deal if you have bigger microservice architectures and invisible event chains. So we know where problems occur, we can tackle them and fix bugs, for instance, easier. I listed on the right side some of the known workflow engines and BPM suites. For instance, we got Pega, Visagi, something like JBPM, as well as Camunda. And for today's session, we'll focus on the workflow engine Camunda provides. And I've built a couple of use cases with it. So we also have a little bit of coding, which we are able to see once we introduce the hexagonal architectures or clean architectures. But now some of you might think, hey, workflow engines, orchestrators, don't they couple everything tighter? So to answer that, let's focus on the question, what is actually orchestration? And especially in contrast to event-driven communication, which we'll hear about later on in this presentation. So orchestration is basically using command-driven communication, and a command is something which we want to happen. And the very important part is that it has an intent. It has more or less a meaning. So for instance, I say to you, I order pizza margherita, you know exactly what I want. And now I can also include, for instance, as delivery option. And it has very well specified intent, which you cannot always say for an event. What an event is, we will clarify later on in this presentation, not at this point. But for sure, you will notice the kind of differentiation between those two kinds of communication. So now we have specified what orchestration actually means. It's nothing more than sending out a command which has an intent. It doesn't mean that it needs to be synchronously. It can also be, for instance, asynchronously sent. Here's a great example. So we have our pizza use case, and there's our chef in the kitchen to make everything a bit more picturable in the head. So we have our chef in the restaurant, and for instance, he says something like, pizza salmon is ready. That could be something like an event. Whether on the right side up here, we do have a great example for such a command. That basically means I baked this pizza, which I just pulled out of the oven, for Andrea. Please package it immediately and deliver while it's hot. So that's quite a good example for command-driven communication, while this is just an event. Awesome. So when working with workflow engines, we heavily invest into those kind of command-driven communications. Here's a little example how you can envision such a workflow engine working. So on the right side, we, for instance, have a REST endpoint, which is being provided by the engine. We start a so-called process instance. In the middle, you can see a process definition, which is the visual definition of or visual graphic of our workflow. In that case, or especially at Camunda, we are using a standard called BPMN 2.0, which is not only quite beautiful to look at, but which can also be executed since it's serialized as XML. And basically we can deploy such a model onto an engine and start a process instance. And the process instance can have specific data entries, for instance, and then we execute such a task called charge credit card. And there we call piece of code, glue code, more or less, which then handles the integration to our credit card service. And all of this is being persisted in a durable state. So we do have kind of a relational database, for instance, right here. And that's how a workflow engine works, quite easily, or broken down onto the most important parts. Awesome. And as mentioned, we are using the business process model and notation for creating these kind of workflows. And on the right side, you can see how it actually looks like. So it is a standardized way of modeling processes, and especially I've heard some talks earlier today about domain-driven design, and they also mentioned, hey, why do we do event storming and all of these things? Because we want to find out the real business processes. But my challenge to that would be, why don't we right away model it in a business process so that the domain departments can actually understand what's going on instead of using purely event stickies on a whiteboard for documenting what's going on in the system or what's going on in the process. So this is a way to capture such business processes, and it's rather easy to understand also from a non-technical point of view. Taking a look on this process model, we can see once our digital waiter in the restaurant James has received an order, we are having a decision, an exclusive gateway, whether we want to take it away or use it as a dine-in or eat as a dine-in. And when we choose or opt in for a dine-in, then we prepare a meal, we serve it. We are waiting for a message to pop up, whether it's ready to pay, and then we are going to issue the check and hand it over. So that's kind of all the process. I won't go into detail what the upper part of the process does, but we won't use it for today's session. We can also react on other events which happen. For instance, if it takes longer than 1 minute to prepare the meal, we can reassure the guest that there's actually a pizza still coming in, that it's in the pipeline. Awesome. Good thing is these kind of process models foster business and IT alignment because you or both sides understand what this process is about, and both can understand where they play a role in it. Besides, I also included the different services which we communicate to. So for instance, there's our digital waiter service right here, which communicates or which is called in these kind of tasks, in these activities. And our waiter service is then handling the communication to the external services such as kitchen or payment. And that's the business process model implementation broken down into a couple of sentences. Cool. The tool which we'll use today, as already mentioned, is Camunda Platform 8. It's the workflow engine of our choice. It's an open source tool. So the ZB broker, as we see here, the workflow engine is open source. Hence, I decided to go for it. It's available on SaaS or on premise. And it provides open standards, which I always like. And there's quite a vibrant community. And for a developer, it's quite easy to use, I would say, which is the reason why I choose to opt in for it. And you will see how this tool actually behaves and its capabilities later on. I won't go too much into details, but for instance, you could analyze processes, you automate, you have little dashboards there as well. So it's quite not only a workflow engine, but quite some tools surrounded. Awesome. But now enough about the general concept of process engines. I want to talk a little bit about clean integrations with you now. And later on, there's a big live demo. You will see how both of these things can interact with each other. So what's the important part when it comes to writing clean architecture? What's the definition of clean architecture? What does it say? And there's this very important sentence that we divide our system into parts, and each of them having a specific responsibility and clear dependencies. So we want to make sure that these two things are done correctly. So responsibility and dependencies, quite important. And ultimately, this will then hopefully lead to better testability, maintainability, scalability, flexibility. All of these kind of things you surely know. When writing clean code, everything gets clearer, better, at least in theory. And yeah, we want to use kind of an architectural style which really makes us work as clean as possible. Awesome. So let's dive a little bit deeper. And now I will present you one concrete style about how to write clean integrations, how to write clean software. And that is the kind of hexagonal architecture, which we'll see on the right side right here. So starting from, I do hear some echo. That's a bit of a problem, but now it works. Great. As I wanted to say, we will start from the domain. So we do have our domain objects, which don't have any outgoing dependencies, and all of them point towards our center. So our domain isn't dependent on any kind of driving or driven systems. For instance, there are is no dependency to our relational model in the database. We purely focus on domain objects, and these objects are surrounded by use cases, and ultimately we do have some ports and adapters. On the left-hand side, you can see in ports, so more or less the driving adapters, and on the right side, you can see the driven adapters or the out ports. We'll see how this looks in code in just a few seconds, I promise. But this is kind of the theory about how such an hexagonal architecture looks like. And the benefit is that whether I plug in whatever system on the driving side or on the driven side, it can easily work. So it's kind of a Lego system. I just choose to opt in with the adapter I want to use. And a concrete architecture for our digital waiter will be presented afterwards. So you have a better idea of how this actually looks like. Right. Cool. So there it is already. There is the waiter, which we talked about, James, and we do have our domain entities called order as well as food. And there are a couple of use cases. So for instance, the waiter can place an order, prepare a meal, serve a meal, pay the meal, issue a check, hand over the check, all of these kind of things, which are kind of crucial for the domain the waiter is in. And it also is the owner of the actual process, which we have seen previously. Cool. On the driving side, we do have, for instance, a Camunda 8 adapter. So we can use Camunda 8 in order to trigger certain use cases in the waiter, but those use cases are not dependent, for instance, on Camunda Platform 8. Any other external system could possibly call them. And on the driven side, on the outgoing side of our adapters, we do have, for instance, two payment adapters dependent on whom I need, whether it's, for instance, Stripe or PayPal, that's open to you. And we also have this kind of kitchen adapter. And if I want to change anything, I can just remove or change the dependency, as we'll see later on. Awesome. And at this point, we finally can hop over to our live demo. So let me quickly exit the slide deck and go over to, first of all, Safari. And I don't want to see my session details. I want to start off with a little live demo about how the digital waiter actually works. And there you will also be able to learn about the tools or about Camunda Platform 8, which I'm using for this demo. So let me enter name. I will take mine, Thomas. I'm going to order the cheeseburger, and I'm going to dine in. So basically, what I do now is I submit the order, and we remember this actually starts a process instance in the back. Now, Camunda does provide a tool which allows me to gain some visibility into the process execution. And there we do have our restaurant Mirano process. That's how I simply called the process, and I can click on it, and I do see the process diagram which we've previously seen. And there is actually a process instance waiting for the customer to be ready to pay. That means basically the pizza has been already prepared. We served the meal, and now we simply wait for the customer to be ready to pay. I can click on the process instance. I can see all the variables I've typed in, for instance, which are inside of that instance. And could possibly, for instance, also troubleshoot if this instance, if something would have gone wrong. I can set retries in here as well. So it simply makes working with external systems a little bit easier and provides out-of-the-box capabilities, which I usually do not want to build when integrating to multiple systems. Cool. Let's go back, and I simply need to select, hey, please pay now, and we can see quite soon that we got the message that our customer is ready to pay, and the process has finished. And our customer has gotten his cheeseburger. We waited quite some time for it, and we received the payment, so all good. We can leave now. And that's the use case or the showcase for today's topic. And now we'll delve into the code for this to run. Awesome. Now you should be able to see IntelliJ. Hopefully you can read everything properly. And I got a couple of services here. So there's our restaurant showcase package or project, or module, better say. And in there are multiple other modules. So for instance, there's our kitchen system. And just to have mentioned it, there is the kitchen controller right here. And this provides simply an endpoint, which we call. But for the sake of simplicity, we simply say the kitchen system is provided externally. Hence, we really want to, at least from a hexagonal architecture point of view, hence we want to, don't have any direct dependencies towards it. Awesome. Cool. Let's take a look on the actual waiter application, which is written in a hexagonal fashion. So you can see we do have quite a packet structure. We do have adapters in and out. We do have ports, services. We have domain objects specified. And maybe let's start with them. So for instance, there's a Pojo for the order. And now we can go a little bit up. We do have these kind of services. For instance, hand over the check, which is implemented as a service. And this one implements a so-called use case, which is defined in, now I need to find it, which is defined in the import. So there's the issue check use case. And related to it, there's also this issue check in command. So everything is kind of similar to an onion architecture in layers, more or less, and separated through interfaces. And taking a look into my adapter, I do have the in and out ones. And for the in one, there's this Camunda in adapter, the worker in adapter, and there we can see how this is actually working. So quickly, let's hop into the process model. And I need to open up the right one. And right here in the process model, I can, for instance, select a task. There is prepare meal. And what I need to add here is a so-called task definition type. And this type is similar to a topic in Kafka, more or less. So the process engine publishes a job or a task for or of this type. And what my code does, or what this worker does, which is hidden in an abstraction layer, it simply fetches all the tasks of a certain type called prepare meal. And there I'm going to call the use case of it. Important to say is that we also have like a prepare meal in command. That means we also have some data transfer objects here, but the command is hidden Now I just need to find it, is hidden in the port, and we should be able to see it right here. And that's basically the essence of kind of the hexagonal architecture. And you might think now, hey, that's quite a lot of code for, oops, I don't want to move this. That's quite a lot of code for such a small use case. That's right. There are a lot of classes, a lot of files which are being created, but especially in domain-heavy services or systems, this is kind of a game changer because I always know where to find what because of this kind of separations. When I don't touch this project for months, I still know where to find what, given the naming of, or the package structure and the naming, obviously, of the hexagonal architecture. So my advice is, especially in domain-heavy or domain-heavy services, this is kind of a game changer and makes coding a little bit easier. Let's put it this way. Cool. Now you've seen the first part of the live demo, how the workflow engine is being utilized and how to structure hexagonal services, or how to build them. And now we continue with scaling things up. So now we add choreography to the mix as well as Kafka. So my hypothesis is to say, with a clever mix of both choreographed event-based style and orchestrated command-based style communication, we can actually reach a proper good level of decoupling, which is something we aim for in software architecture, right? So let's go over here and take a look on how these two ways of communication differ from each other. So we do have choreography, which uses the event-driven communication, as already mentioned before, and an event, in contrast to a command, does not have an intent because it's a fact which always happened in the past. So right here we do say, for instance, hey, I'm hungry, and I'm throwing it out to you. And I see more than 50 people are in this call, so maybe some of you is going to pick up the event and prepare a meal for me, but I doubt it. And maybe multiple people pick it up and also prepare a meal for me, and the first one coming with a meal, wins, because then I'm already full, the hunger is satisfied, and I don't need any more food. So that's kind of the problem of event-driven communication, right? Because this, what has happened, has always happened in the past, and we not necessarily as a sender know who picks up the event, if any picks up the event. So that's kind of the challenge we have. Cool. Also worth mentioning, we only want to throw these kind of events if, for instance, we update, write, or create and delete data. Not just for reading something in our database, that's for sure not worth throwing a domain event. That's something which we'll also see later on in the live demo again. Now, we simply, or not simply, but we want to apply at least some practices for or of domain-driven design, since it's approach for software development that helps us grouping our parts which we've created in the clean architecture, related to the domain. So we also focus on the domain and make sure to split up the parts properly. Okay, and therefore we for sure need to have an understanding of processes and rules of the domain, and the processes we've seen previously for sure help doing so. Cool. One very important concept, and I won't talk a lot about DDD now because there have been plenty of talks today. Hopefully you've attended one or two of them. They've been at least fun to watch. the most important concept for this session is at least the bounded context, because now imagine our restaurant runs so well, we can purely use our digital waiter, James. We do have quite some human waiters, which can now do some other tasks, such as quality assurance. So what they will do in the quality assurance department is to call the customer afterwards to check in with them and see how their experience was in our restaurant. And this is a completely different domain than the restaurant context we've been in previously. Hence, we don't not want to extend the process which we've created previously. Rather, we want to create a new system, a new process for that purpose. Nevertheless, there's, for instance, something like the order, which is a shared concept. So an order is relevant for quality assurance as well as for restaurant context. That's important to keep in mind, especially when working with these kind of things. But what does this mean for our architecture? And we are going to evolving it, transition it into something like this. So we do have our waiter, which stays more or less the same as we've seen it previously. But now the use cases publish or create events which are being then published by our Kafka adapter right here. So the Kafka out adapter then publishes the main events in the message queue, and we can actually consume them in our satisfaction service. And there's our Kafka in adapter. And the satisfaction service handles or is responsible for handling the satisfaction survey process, which we'll see later on. And we do have various domain entities. We have a use case, for instance, start the process. So basically what happens is we publish an event, consume the event, and we'll start a process, a new process on consumption of the event. And that's kind of it. But it's quite a good example how you can use event-driven communication. So let's take a closer look how and when this is actually being done. And therefore, we'll take another look into the code. Awesome. Cool. Just to have shown it before I forgot, there is our customer satisfaction survey process. So basically, we'll start it with a message. Then we do have a user task. So a clerk or one of my previous waiters need to pick up the task, call the customer, and then they can check in some details. And that's kind of the process. Nothing more, no complex logic. That's basically it. But how is this triggered? So let's take a look into the code. So first of all, we'll start with the waiter again, because I want to show you where the events are thrown. So first of all, the domain, which we do have here, also keeps track of all the different events which exist. So all of these kind of classes, which we have here, objects, which we have here. And we are going to throw these or create these events in our services. For instance, we do have a pay meal service. And there we are going to create an event and publish it accordingly. Once having done so, it's only being published in the context of Spring, our Spring application. We still need our, it's in the out package, we still need our Kafka adapter, which is then responsible for publishing it to actually Kafka. So we do have here the event listener, and then we publish it to Kafka, to a Kafka topic. Awesome. And then we can listen on it. I do have Visual Studio Code open up here, where I do have configured a nice plugin showing me what's going on in Kafka, and I can see all the events which have occurred here. Yeah. Now back to the code. I will quickly open up the satisfaction service, which is built very similar. We do have an adapter with a in Kafka package, and right there we do have our Kafka consumer. We listen for a certain topic and only want to have an event basically when, let's go back into the process. One moment. We want to trigger our satisfaction Miranon process once the check has been issued or something like that. So I only listen to one event, not all of them. And also something very important, this process, which we do have here, doesn't need to wait for return of our satisfaction Murano process of this service. So they are completely independent from each other since they are two different domains, right? Awesome. And that's simply what's happening here. And once having done so, I do start a process instance by sending a message over to Camunda Platform 8. Awesome. Let's check it out again in a live fashion. So now I'm going to say, Klaus, who wants a pizza margarita for takeaway, is submitting an order. I can take a look on my dashboard. And right here, we can see how the process continues. And hopefully it is finished soon. We are waiting. Oop, your payment is being processed. Let's see. Yeah, now the instance is finished. That's great. Cool. Now we should have gotten 2 tasks. And that's what has happened. So one task, which was created initially. So there Thomas ordered a cheeseburger for dine-in. And I now could say, hey, let's call the customer. And the cheeseburger was not so great. So I completed. And we do have this customer, Klaus, who ordered the pizza margarita. And I can say, hey, I called the customer and the pizza margarita was very great. So that was kind of a showcase how we have 2 different systems, each of them containing a process, and how they can actually communicate with each other by using the concept of choreography, of event-driven communication. Awesome. Having said so, there are some takeaways for throwing the right domain events. First of all, it's always important to not reuse the same events, because then usually semantically an event can mean different things, which we don't want to have, and always use clean names. That's kind of very important, as for sure you all know. Clean code and so on and so forth are quite some popular books which talk about this quite some time. And we also only want to throw events when manipulating data. Yeah, as already mentioned as well, we do not want to expect something in return after having thrown an event. And yeah, try to use this kind of communication only outside of the bounded context. And for the overall talk, because we are coming to an end already, for the overall talk, the key takeaways are that we want to try our best to design services in a technology-neutral fashion. I don't want to have any direct dependency in my use cases, in my domain services on external systems or external infrastructure elements, such as a database like Mongo, Postgres, whatever. I want to keep it technology neutral, to have the freedom of choice or to have the flexibility whenever I need it. I need to change a vendor, for instance. We want to use domain events for communicating outside the bounded context. As already mentioned, we do gain for sure a better maintainability by using something as a hexagonal architecture, because even though when you design or create a layered architecture, at a certain point in time, it for sure will get dirty, and the dependencies are, yeah, can be improved, let's put it this way. And last but not least, for an ideal decoupled architecture, both is important, choreography and orchestration. It's not kind of a choice you need to make, whether it's using Kafka or something, some kind of orchestrator. You can do or can use both to really decouple your system as you like. And with having said so, we are at the end of my talk. If you have any questions, let me know. Throw them into the chat. I don't see a red bubble there. There's the GitHub repository where you can find the example. Hopefully, no, I think the QR code works properly. If not, let me know, then I can post the link. Yeah, having said so, looking forward to see your feedback. The presentation is already uploaded to, forgot how the tool is called, Chat, genau. So the presentation is uploaded already, and I think you can submit feedback for the talk, and I would be happy to read something about this. So yeah, that's it from my side. Thanks a lot, and have a great rest of the day or evening. And hopefully we'll meet tomorrow again in one of the upcoming interesting sessions. Thanks.
Yeah, thank you so much again, Thomas, for your interesting insights. And if there are no further questions as of right now, we finished this session for today. I think there's just like a question in the chat if you want to have a look, Thomas.
Now the question is, what the heck is a SPOF? Let me quickly Google that for you. Single point of failure. Yeah. Okay. The workflow engine can be redundant. So you can manage to create an architecture where the workflow engine is basically redundant, and then you don't have the single point of failure. Yeah. But usually at a certain point in time, you always can argue that you have a single point of failure in your architecture, whether it's a huge Postgres database or something like this. It can always be held redundantly, and that's also possible for workflow engine. Yeah. Share the code. Yeah. Correct me if I'm wrong, but the code, let me quickly find my session. It should be uploaded in there, isn't it? Maybe some of the moderators know. I just need to find my session. One moment. There it is. Oh yeah, it's in there. So here comes the link, and you should find under the speaker information, maybe for that purpose, I just share the screen again, right here. So if I open this website where you can see this session, scrolling down, there should be this kind of PDF file, which you can open and download, which contains the presentation. If this doesn't show up, I don't know how to fix it.